but it was a challenge actually. So the challenge was create a real-time system that can show the current situation on the airport. So if you've been to the terminal, you've all seen the monitors, the displays with arrivals and departures, so you can see the actual state of the planes, like they're delayed or they're coming in early, or my bag is coming at a certain baggage belt, so I know where to pick it up. Those are all events. And well, there's lots more of information to be found at the airport. And we had to create a system for it, so like a web app. There's people managing this airport, and they tend to get a phone call like, well, it's really getting out of hand at Terminal 3. So there are too many people there, so we should do something. And then say, well, open all the desks, send all the security personnel there, so we can check more people, so the flow of people gets faster, so we can resolve that situation. So, well, that's very reactive, so we want to do that a bit more proactive. So we want to build a system that will tell them, well, in about 2 hours it will be very busy at Terminal 3. And the ambition is to be able to have the people in the tower have actually sent a gate change to the plane in the air to land the plane at a different terminal, so the people will go somewhere else. So that's a big ambition. We're not there yet. And there was nothing yet, so, well, we needed some really clever ideas to build that. So we went looking, we found this guy, Martin Fowler. Maybe you've heard of him. I'll try to zoom in a bit. Or I won't. So, he says, capture all changes to an application state as a sequence of events. So, how does it work? Well, let's consider a simple example to do with shipping notifications. Well, let's not do that, because that sounds very boring. So the next one, event sourcing. Well, this is a pattern that emerged around 2005, which is 12 years ago. And now it's getting a lot of traction in the front-end world. So maybe you've heard of React or Angular or other frameworks. They're using ideas from event sourcing, actually. So if we read here, you can use event-driven architecture to solve the distributed data management challenge in the microservice architecture. That was a nice sentence, I suppose. A great solution to this problem is an architectural pattern known as event sourcing. Well, consider the order entity. Yeah, let's not do that. Okay. Oh, we're going way too fast, sorry. Event sourcing is awesome. A powerful and simple way. Why event sourcing is great. It's a pattern for documenting the state of your system. So we want to document the state of the airport actually. So we need something like this. So let's take an example of an order that is ready for shipment. So I don't know what's with these guys from event sourcing. They're talking about orders and about shipments. Well, like your bank account. So you take €5 from your bank account. So you have the balance, and we do -5, and then we have the new balance, right? That's not a very good pattern because it's well prone to errors. Well, let's take things a bit more light-hearted and talk about Space Invaders on the Super Nintendo Entertainment System. There we go. Let's see if the full screen works. It's not actually, because we cannot see the score on top. Well, these are Space Invaders. There's actually a player down there. And the score needs to be increased as you hit aliens, right? So that's a bit interesting than orders and shipments. So how are we going to do that? Some clever tools. Reactive programming. Sorry, I won't quote this. But somewhere I read real-time programs are usually reactive. So okay, well, we need that. So we need event sourcing and we need reactive programming. And then we can start solving things the reactive way. So consider the events that change the score. You hit an alien worth 50 points, 25 points, or another 25 points. So the score should probably be 100, right? We can do that. So we have events and we have state. We can write some script for that. So we have the score, we start playing, we have a score of 0. We write an event listener. So most of the people are familiar with JavaScript. So, well, this is some custom event called hit. And then we do score equals the score what it was before. And add some calculate points. So maybe some aliens are worth more than the others, so we have to calculate the points of that hit. That's all very nice. We have some nice arrow functions, so we can be proud of ourselves. Well, with reactive programming come a lot of paradigms. Well, we also have reactive programming, reactive X, for the people who know it. It's available in a lot of languages, like it started out also in the Microsoft corner, I think. It's available in Java and a lot of other languages, and ArcGIS is the one for JavaScript. So we can see a different thing here. We have a hit, and we create something called an observable, which actually is scheduled to become part of JavaScript at some point in the future. And we can say, well, we want an observable thing from player 1, and it's called hit. So maybe some of you know promises, they resolve, and then you have a result. So this is like an observable stretched out over time. And you have array-like methods on them. So we can calculate the score as well. We take the same hits. We're going to reduce hits. So we start with a 0. When the hit comes in, we take the score, what it was, and also the calculate points. It's very similar to this one. Actually, this one is a little bit simpler. But here we have a problem. So we have to score outside somewhere in a certain scope. And we're going to have problems there because if we flip over the box of Space Invaders, we can try the original mode in 1 or 2 player arcade fashion. So, multiplayer. We have 2 event listeners. We have a score. I should have renamed it to mutual score maybe, so the player 1 can hit stuff and player 2 can hit stuff. And we need to calculate the points, and we don't know exactly how many times that calculation will take, right? So we don't know actually who will update the score first. So I think we have a lot of arguments with this code. One of the nice things is to maintain state. So all of the Redux fans in the room will say, well, we have a store for that, and we can put stuff in it. Well, that's great. And that works very well, and with the ArcGIS you can contain it in the pipeline actually, so there's no variable score outside of this. So we create 2 observable things, player 1, player 2, and they have some excellent operators in ArcGIS, like the one called merge. So we merge the hits of player 1 with player 2, and then we have actually the same calculation for the score at the bottom. So that's our things that are happening in the Space Invader world, and now we want to observe those things as spectators. So we start our browsers and we're going to watch something like Twitch, but then better because Twitch is a streaming movie and we're going to watch actually a stream of this game. We can have the merge there of the events, so player 1 hits for 50 points, player 2 hits for 75. We don't care about the order actually, but the events are merged, so they are numbered from 1 to 5, and the state is on the right. So you can see what happens to the mutual score. It's a cooperative game, obviously. So what we need to do, this is the most technical slide actually, so take some time to digest it. We will get the state, and we are having a spectator A which logs in at a certain point in time, and it gets, well, the state is 125 points at the moment you logged in. And you should remember that it was version 2 of the state. So that's the event sequence number. And spectator B logs in a little bit later, it gets 200. And it should remember that it has received version 4. So we just subscribe to a WebSocket for updates. It's as simple as that. Right? Live demo, or it didn't happen. Okay. Let's go to the live demo. Let's see if we can make some real-time airport thingy going on. So get your devices. And we can all go to this URL. Oh, we have some very quick people there. Tamara is flying. This is the easy part for me, actually. So I'll let you do the work. So the challenge is, can you process a lot of events simultaneously to show a certain state at a certain point in time? Who's that? Ian. Okay, so you can change colors, you can change lanes if you want. If you want to land your plane, just press the little gray area. And if you landed, you should put the lights on. That's actually required by law. So. Okay, I want to do a little experiment with all you guys. If you can see, are we really real time? So I'm going to count to 3 and I want all your people to land, right? So, oh no. Well, it's a small airport, sorry. So at the count of 3, all press the little gray area. 1, 2, 3. Almost real time. Okay, can we change maybe at 1, 2, 3, change the color to red? So 1, 2, 3. Yeah, it's pretty okay. It's almost like a real-time airport, yes, but I promised something else. So I said we have 2 spectators. My laptop is actually still alive, so that's nice.
So many connections.
Yeah, I know. I'm sorry. There we go. So we have a second one subscribing. And it's getting all the events. So we have now a Firefox airport. You can all fly, or if you want. You don't need to stay landed. Yeah, it's starting to look more and more similar, so it's catching up. Oh, sorry about that. I'm going to inspect one of these guys. There we go. So here we have the stream of events over WebSocket. So we see all the events coming in. So we've actually created a real-time airport in a very small context. This is what we do in real life for the actual people at Schiphol. And we're having a lot of fun. So we're using event sourcing, Node.js, RxJS, and it has been great fun. So thank you.
Also, if you note, no